Okay, so I guess we can go ahead and get started with the next panel. People are getting settled. So yeah, so looking forward to this next panel. So panel 2 is on virtual reality. So as the last panel kind of discussed, there's sort of this continuum between the real world and augmenting the real world and overlaying things and a purely virtual world. So everybody on this panel is working in a purely virtual world. So whether that is have the headsets and you're totally immersed, or it's a virtual world that you're accessing through a computer. So that's all these guys. So I'm not an expert in VR, so I'm gonna let them introduce themselves, and we can ask questions and see what they're doing with this stuff. But just to sort of contextualize a little bit, so virtual reality has been around a lot longer than augmented reality and some of the other extended reality things. So there's a lot more depth here. We've been talking about virtual reality since Tron, the original Tron. So it's been around for a while, and we've been playing with how to use these tools, and we have a really diverse panel, people using them in a lot of different ways. So I guess let's just start with Nantia on the left here, and we can just go down the row and then get questions in as we go along.
Hi, my name is Nantia Sithana, assistant professor in neurosurgery, psychiatry, and psychology. Do you want? Sorry.
I'm
just
sorry.
Name or
get name, kind of what you're working on. Just give us a little
okay.
spiel. Yeah, the elevator
I'm a
pitch.
neuroscientist, so I study how the brain works, and I work with patients who have brain implants that can record deep brain activity. So virtual reality is a great opportunity to test, real-world human behavior and cognition in my laboratory.
Hi, I'm Peter Oberdorfer. I run a digital agency in San Francisco called Tactic. We do VR, AR, 360, mixed reality, and real-time experiences, sort of immersive experiences is what we specialize in. We do some projects, that are commercial in nature for products and brands and direct-to-company type stuff, and then a lot of mobile apps for that. But then we also do projects with Oculus and commissioned films, things like this for short film form type of experiences on higher end headsets. So.
Hi, my name is Sasha Samoshina. I work at NASA's Jet Propulsion Laboratory, which is a NASA center specializing in robotic missions to space. It's in Pasadena, California. And I work in a department called the Ops Lab, which is a cool little place that's part of JPL. And we specialize in VR, AR technologies. So I'm a producer on some really great projects in that department. And we do everything from actual virtual reality to, incorporating that with the web, and looking forward to sharing some of those with you.
Hi, my name is Chris Araujo. I'm the Senior Virtual Pre-Construction Manager for a general contractor in Santa Monica called Morley Builders. Because we are the Virtual Pre-Construction Department, we specialize only in virtualizing projects. We work for the estimating department, so essentially we're working on things that are not yet built. So the goal of our department is to figure out exactly how a project is going to be built and to determine how we can do it in the fastest possible time and basically for the least amount of money at the benefit of our client. So we work in virtual reality, augmented reality, and essentially, anything that's three-dimensional that you can do on the computer we play with.
I'm Deidre Whitmore. I run a digital archaeology lab on campus, and then I also work on building a data publishing platform for an academic press. So I dig in the dirt a lot, but then when I'm in the virtual realm, we're taking those and moving them into an environment that can be shared more readily with others. Yeah.
Cool. So I guess just to start off, I guess maybe Peter, but then everybody else can answer this. So basically, virtual reality lets you create these really immersive experiences that sort of pull you out of whatever you're doing and really engage in something in a very full way. So how do you use this technology to basically hook people into the concepts you're working on? And if you had a few examples to sort of illustrate, that'd be cool.
Well, we're just finishing one this week, for instance, that was commissioned by a grant from FEMA and Environment SF, the city of San Francisco. And it's a pilot program to use in coastal cities to show the effects of climate change and sea level rise along coastal cities. And so we're working with the city to visualize, mitigation strategies and things like this, but we have signs up around the city. They're going up later this month where people can go and then see from an online experience or an app experience in 360 what sea level rise will be like in 40 to 70 years, depending on the theory, and 3 to 5 feet of sea level rise along the coast. And we visualize that immersively, and then we show mitigation strategies. So 2 possible futures really, and then we also go into current day and capture data and things like this. And for this type of thing, I think what's effective about it is that you really get a first-person POV in a way, it's experiential in a way that this type of information doesn't connect with everybody in other ways. And so I think, yes, there's a novelty factor, but then I also think, by putting somebody in the pilot's chair, so to speak, you do kind of get a visceral reaction that we wouldn't get otherwise. So, and I do think there is some discovery there too. People are hearing about VR and AR and things like this, so that's a selling point. But once they see it, I think the first-person nature of it does stick in ways that other experiences wouldn't.
Yeah, lets you play with it a little bit.
Yeah.
I guess the other thing I was curious about, and this maybe is a little bit more towards Sasha's stuff that you do, but sort of thinking about sort of the artistic expression point of this, where you're basically, it's not art, but in the sense of bringing people to these larger-than-life places that NASA's bringing you to. Like, what is the sort of your artistic flow in terms of just really thinking about how to design that and communicate what you're trying to communicate, but in this very immersive sort of, it's a different way of
Sure, yeah, it's fun. I like talking about the cross-section of art and science a lot because I'm actually an artist that, excuse me, loves science, and I happen to build this career based on that thought alone, and I am a huge proponent of saying that they're not mutually exclusive and that they kind of need each other in this beautiful way. The way that I got inspired to even think about things in virtual realms, aside from studying it in college, was I started making 360s for my old department when I was a multimedia specialist for the media relations department. And it was basically when the API came out for YouTube and Facebook, and they were like, you can put panoramas in 360. And I was like, we have Mars panoramas from actual Mars that are already stitched together and approved by our science team. So I think the creative spark there was actually taking real information and putting it into kind of a new form for people to ingest and learn in a way that they are not used to. Right now, the projects that we're working on, one project in particular, if we're going to keep on the Mars beat, which is quite popular with people, I hear, we have an application for the Microsoft HoloLens called OnSite. So it's actually taking data from the Curiosity rover and Mars orbiters, and when you put on the HoloLens, you can actually walk on real Mars, and it gives depth to everything. So you can look under rocks, you can crawl around. It's really something that's been used by our scientists to study, usually, actually geologists mostly. So we have a TikTok.
Yeah, I was just going to say.
I know. I was like, please come do this. So, before they were using anaglyphs to get depth of things, and now they can actually virtually meet up in a multi-user session on Mars and kind of see what they want to image and see what they have imaged. So if one rock seems blurry, they can be like, oh, to the rover driver, could we possibly have Curiosity image that rock in the next couple of days? And then when they put the HoloLens back on, that becomes more high-res. So it's kind of this beautiful thing. And then as a producer for these things, I come in and I'm like, okay, this is a science tool, then how can we, take this and put it in the public's eyes? So that's kind of where the artistic part comes in. So either telling the story to the public, or there will be something coming out shortly for all of you that uses the same data that we use in OnSite. So that's really exciting.
Cool. Deidre, did you want to kind of add to that at all? I mean, because you're basically more on the archaeology side of things.
We're best
but
friends
it's also,
now.
So to bring people to space, you're bringing us back into, history and, our past.
Yeah, I love that you mentioned the interaction between taking what you're using for researchers and then extending it out to the public, because I feel like in archaeology we're sort of doing the opposite. We've seen the fastest adoption in more of a museum context. So they're creating virtual museums where if an audience isn't able to go to the actual physical space, they could still walk through the museum, see the same objects. But then I'm trying to figure out how we could apply it more as a research tool that would support archaeological data. And so connecting it back to the database.
Right, something like this application makes sense. You know, we're taking on-site and also using it for scientists to plan the next Mars mission, which is in 2020. So it's kind of like this growing thing. It's one idea that then, and it totally could be something that, you know, we should talk.
Let's hook up later.
We're just gonna, we get into, everyone else is like, what's happening?
So I had a quick question for Chris. And this might be totally off base, but I'm just thinking about using VR in your setting, which is you know, designing architecture and in construction. I would imagine that it will allow you to do to iterate through things more quickly and in a more immersive way, so you can take a little bit more risks and then see, like, because it's immersive, you'll have a better idea of whether or not it's going to actually work or not. So you can take more risk and then play with it in VR. And then is that true, or am I just totally?
To a degree.
Okay.
So we have the ability, I mean, we can work in gaming engines when we work in VR. So the modeling software that we use, it's very adaptable. The models can be exported out and they can be brought into a variety of software. So you can use Unity gaming engine, for instance, and that actually has physics built into it. The limiting factor to that is that the model, once you've exported it, is basically one solid piece. So you don't really get to play with physics outside of you being the person walking through it and experiencing the physics of it. But I'm hoping that, I mean, I kind of get to be, I think there's probably going to be one in every panel, I kind of get to be the bubble burster on this one, because we're just not quite there yet, especially not for architecture and construction. We have a lot that's available to us, but we still need a lot of help. It would be nice to see some sort of engine that was actually made for virtual reality that could be used by architects and other designers and construction companies, you know, things for structural analysis, that sort of thing, that would get us to that point.
So I want to talk about this for a second, because we have another program that actually takes CAD models and puts them into three-dimensional space. And you can granularly kind of take things apart based on the model and do real-time editing and collaboration. And we're now working on something where you can also like do authoring based on like locking in the actual thing to the model and then doing something before you actually have to do it. So that seems like some kind of technology that would seem really applicable to.
I think so. It's really just more so that.
More engineering-y.
Yeah, I think it's also more, you know, when you're talking about construction, you're not just working in big pieces, you're working with all different kinds of materials and finishes, and you have, you know, really, really detailed, like down to the nuts and bolts is really the way that you would have to model it. So everything just gets so complicated and things just get bogged down that the ability to actually do that, yeah, like I could probably do, you know, for instance, in construction, one of the things we do, we call it a mock-up, which is basically we take a small piece of the building and then we expand that out, right? So we take a small piece of the building and we build it in the field. And we could probably do like a digital mock-up, and that would actually have all the bits and pieces.
Right.
But I think for a larger project, we'd need to have somebody like Autodesk come out with something that's actually designed for the construction industry.
Yeah, it's amazing to me that Autodesk doesn't have a game engine that works with, you know, or that Revit doesn't have this type of functionality.
I think
building
they're
in,
working
you
on it.
know?
There's a lot of people who've made plugins and add-ins for Revit that'll actually let you export out to Oculus and that sort of thing.
Right.
Yeah.
Right. Yeah. Yeah, there is a disconnect still, though.
A little
you know,
bit.
and the gaming
Yeah.
industry was so insular for so long that the tool sets are just emerging towards other industries, I think, in a lot of ways.
Yeah, it was definitely built for the gaming industry, and we started playing with it, you know, back when Unity became like a popular thing. And you could tell, you know, you're doing first-person walkthroughs, and in some instances, I actually had to be holding a gun because that was the only way that I could have a character
Yep,
walking through my
exactly,
game, which was
exactly.
my building. So I'm like
First-person
running
shooter.
through my projects,
Yeah.
and I have like an assault rifle in my hand. It didn't feel right.
It's very topical. Yeah.
So I wanted to ask everybody what technology they want to see coming out in the next 5 years. But before we get to that, I wanted to ask Nantya. So you're one of the few people that are doing actual research and using VR as a tool to actually collect the data as opposed to doing reconstructions after the fact. So I guess first, since everybody's not in the neuroscience, neurosurgery world, just maybe say what your setup is and kind of how, because you're also doing the brain recordings too. So just quickly what the setup is, and then the second question would be, how does, you know, with virtual reality, you're basically able to create whatever environment you want. So how do you use that freedom to ask the specific questions that you want to ask in a way that you couldn't if you were just dealing with people in a regular reality?
Sure. So first, the setup. So we have a room about 500 square feet down by the medical center, that we have essentially, these motion capture cameras. All of our patients wear these full body motion suits using infrared reflectors. So we get sub-millimeter motion, tracking essentially. That is integrated with a wireless. We use a wireless, the Gear headset, because we want the patient to be able to walk a wide space, so the Vive doesn't work for us. So the motion tracking system is integrated with the VR headset, which is integrated with the implant. So we have this very extensive, took, I don't know, the first year of my lab to try to figure out how to sync all these data streams. We also have a EEG cap, so recording outside brain activity. So all of these systems are synced with essentially like an electromagnetic marker that can input wirelessly a mark in the device that's implanted in the brain, and the EEG and an LED goes off, which the cameras pick up. Anyway, it's like complicated. But finally, when we got that to work, it presents a huge opportunity, which is really for the first time, we can record from a human being, so not an animal or a rat, which is running around in a maze, but a real human being while they're walking around doing a controlled experiment in VR. So classically, memory, which is what I study, how people form memories and recall memories, we do it with, in the old days, cards, and now with computers flashing images on the screen or words being presented. I mean, that's not naturalistic, it's not ecologically valid, especially if you want to develop a therapy for people with memory disorders and test it out. If it works in this very limited environment on a computer, how does that actually translate to when they go home and want to find their keys in their house or navigate a new city or has Alzheimer's disease and gets lost, in a familiar environment, or, you can imagine. So there's twofold purposes in the lab setup we have, which is one, to characterize what's happening in the brain during real life activities. And then two is, how do we develop therapies and test these therapies out in a realistic way that can translate to the real world? So that's the setup. It's quite extensive in terms of hardware and everything, but we have a good team of engineers and physicists and virtual reality designers. So
What would you like to see happen in the next couple of years in terms of I could really use this tool if it existed? And then everybody else, I want you to answer that too, but we can start with you.
this tool, let's
What's
see.
the pain point, or what's the limiting? Or
I mean, with anything, so I'd like to see more wireless headsets, which are coming, but the one we're limited to just one right now, which we're limited by the latencies and the Wi-Fi connection and all this nonsense. So, it's much better than it was before. I get motion sickness with everything, and if it works for me, it's pretty good. These are patients with epilepsy, right? So I want to make it the most comfortable thing possible. No wires, they can't trip at all, right? So I'd like to see technology that is better and taking advantage of faster latencies and.
Because you're basically limited by the computing power. Like if it's totally untethered and they have a diagram, it's based on how much computing power you can have on it.
Yeah,
Okay.
and it's pretty good, but I want to get it. I would like to see it get better.
Okay.
Yeah.
Peter, what about you? What would you want to magically appear to? to do cool
Well,
stuff with?
I mean, yesterday at Oculus Connect, they announced a $200 headset that's sort of midway between the mobile-oriented Gear VR and the tethered headsets like the Rift and the Vive. And not having tried that yet, you're starting to see things like this and another generation of headsets coming up next year that have higher resolution, doubling the amount of pixel density that you have so that the immersion is just that much more. And then you're starting to see headsets that don't require external tracking that come from the HoloLens 6-space kind of internal inside-out tracking. And so all of these things are kind of converging, and I think the price point, along with the fidelity and resolution, along with portability, all these things are improving pretty quickly. And I look at the first iPhone to now, and you start to get excited because you think, well, this stuff is maybe kind of junk now in a way. It's 1.0, but you see where it's going, even in 2 or 3 years, and it starts getting pretty cool, pretty fast.
Can you just explain that real quick? So I've still been learning about VR in the last year or so, but just the inside-out tracking versus having kind of the external things tracking. Can you just sort of explain how it's done now and sort of
Well, it references what she was talking about. Like we have seen some larger capture spaces where you have multiple towers that externally track your positioning, and then but it takes quite a bit of hardware.
And also the head orientation or just the position?
Everything, yeah, and 6 degrees of rotation and translation sort of through space, but you're starting to see with the HoloLens that although that device was a bit unwieldy for consumers to buy at $3,500 a pop, that core technology, tracking technology, is being applied to sort of OEM headsets that they're licensing, that Microsoft is licensing out. And they're doing that for VR and mixed reality headsets now. So Samsung's coming out with one, and a bunch of other companies will be following suit. And these are going to be at a lower price point, similar to the Oculus, maybe cheaper. We're looking at $400 now for a lot of it. And they, although are still tethered, they allow sort of a lighter setup and a more integrated setup so that you don't have to be within a particular space per se, and you can have a backpack system, for instance, that allow you to fairly accurately track through a room.
It opens it up a little bit.
And
more,
it
more
opens it
people-
up.
yeah,
If I can do brain recordings while they're literally navigating their home
Oh, that would be
environment,
cool.
that would be better, right? Than
Yeah.
more synthetic
Yeah.
space.
Yeah,
So that, yeah.
yeah.
What about you guys at the end of the table? Is there any things that you're sort of hoping for in the next couple of years as things develop?
Yes.
I
So
have a list.
my particular research focuses more on data management and reuse of archaeological data. As you can imagine, it's expensive to collect. A lot of times it's destructive, so you can't go back and get it. Because of that, I want to focus more on the software that's capturing it. And as I think if everyone here heard what Lisa was talking about, it's a painstaking process to reconstruct these models, and you're analyzing text to try to figure out what color that paint was, and you're making a decision in that process. So if there's some way to annotate or to call back to the documents, the data that is producing these models, and to have that tracked and then presented nicely through the software, that would be wonderful.
My list.
Somebody's writing this list down, right?
And working on it.
I think the good thing is that where I'd want to see this going in 5 years is probably where it's going to go in 5 years. What I would say the biggest thing is industry adoption outside of certain small industries, because the more that people adopt the technology, the more they're going to work on actually advancing it. So really, where do I want it to go in 5 years? I want everyone in this room to have a headset in 5 years. Because if everyone in this room has a headset, then we're all going to benefit from that. Like the companies that we were talking about, they will make that software. They will make things easier for us to access. Right now, computing power is a big issue with a lot of people. For virtual reality, it requires a lot of computing power. Those things will be more accessible to the rest of us on a consumer level.
Do you have thoughts on the using the phone as with the Google Cardboard thing versus a dedicated headset? How do people land on that?
We've actually done it. So there are a few apps that make it really easy for us, even with the buildings that we work on, like the large projects that we work on. There are a few apps that make it easy for us to load that onto a phone, and we can hand out. Yeah, so it's pretty neat because you can be in a client meeting, for instance, and you can have a bunch of people sitting at a table. You have all these, people who are looking to build, and for a general contractor, we build projects that are several $100 million, so they're big projects. And you can have those people sitting at the table looking at their building, and they're all sitting there with this little $2 cardboard accessory in their own cell phone, and then they can take that home, and they can look at it at home, and they can make decisions on
Show
how
the
they want
kids
their
or
building to
whatever.
look and function, show the kids, show the wife. Yeah, exactly.
Do you think that it's more likely that in terms of kind of putting it out to the masses that people kind of have dedicated headsets, or it'll be more of kind of building around having the cell phones be able to give those experiences?
I think in AR that's the case, right?
Yeah.
I think that's already being worked on.
Everyone has cell phones.
That's gonna, I think, make it more a thing that people are used to once that becomes part of the process of, I think headsets are great, and we do a lot of our work in mixed reality, so we're using the HoloLens a lot. I always wish it had kind of a bigger field of view, and we have to write a lot of custom code around the actual hardware of the device, and when they do an upgrade, that shocks our whole system. So making that more streamlined, I wish it was all open source. That's never going to happen.
Yeah.
But you said dream big, so I'm dreaming. But the thing is, I think when people kind of realize real life applications of it, so a lot of the work that we do, like with Protospace with the 3D CAD modeling tool, which basically takes CAD models out of 2D into 3D in real life, in real size. You can see your spacecraft, you can see your rover. I mean, you can maybe see your building, in the future. You can take it to many levels. So our engineers use that to kind of plan things, and sometimes they're like, oh, I actually can't fit my hand through here. We should fix this. And so it's like real-time editing with seeing it in real life. So, but if they didn't have to have a HoloLens to view all of this, if they could do it from a desktop and then maybe view it through their phone, I think that would kind of change the game with how accessible it was. So I know I would love to have every customer we have to, every scientist that we work with, every engineer to have a HoloLens next to their desk. But, at this point, it is a very high price point, and you can't expect everyone to understand the problems that come with it. Sometimes it just doesn't connect to Wi-Fi. And it's like, they call us and then we do all that problem solving. I can't expect every single person to have the time to troubleshoot this particular device.
Yeah.
So like streamlining the process, and it's gonna be a heavy lifting job, but I think it's gonna be fun,
Yeah. I think the HoloLens is much more suited to NASA than it is to the living room right now.
Yeah.
And that's why you see handheld AR with ARKit and AR Core, like Apple and Android phones, being prevalent for AR with consumers for the most part.
And companies like Sketchfab coming out with like the ARKit that you can use. It's great. It's just a lot more utilitarian, and I think web VR is going to change a lot of that as well.
Yeah, and these are sort of like, it's like the price point and all the things, that we had talked about, fidelity and portability. These things are all kind of in different places now and converging more.
Yeah, more than they were a month ago.
Right, yeah.
This is more of a unified view than like the VR versus AR sort of battle that we saw in the previous panel.
Oh, yeah, that was cool.
Yeah,
Because we're all agreeing.
Yeah, I mean, I think it's mainly just a waiting game. It's a waiting game.
Yeah.
It's all merging. It's all
Or
going
there's different
towards.
niches for different things. So.
But there are niches by budget and use case and things like this, and that's largely because of where the technology is. Mm-hmm. The canvases that we create things on are basically in these categories now, but I see them merging over the next 3 to 5 years. Mm-hmm. And the medium is sort of fluid and will go where the technology allows everyone to go.
So this is kind of a general question, and I guess if we had immersive journals here, it'd be more appropriate for that, but you guys might be able to answer it as well. I like thinking about the types of content that you can have in a VR situation versus something like writing a news article or writing something in paper or showing even an image. And I don't work in this field, so I'm curious to hear what you guys think about this, but including smaller details and things that would normally be too boring or too simple or too small to include in something you can put in VR. So you can spend a lot of time, like you mentioned the rock. I mean, you're not going to mention a rock in a news article, but in a VR experience, it makes a big difference and it allows people to engage in a lot smaller details and a lot more nuance. So I guess I'm curious if you guys have felt you're able to bring in a lot more nuance and detail, small details into the content because of VR, and how that's changed what you can talk about and what you can bring into the experience. Does that make sense?
Wait, can I talk about the rock for a second?
Talk about the rock. Yeah, that's basically what I was.
I just really want to expand on the rock. What I didn't mention, rocks. What I didn't mention was also, before, the way that scientists looked at a rock was just a picture of a rock, and you had no idea how big it was. And that was the point there. So it's like, you think it's giant and it's actually this big when you look at it in VR, because you have more of a sense of scale. Mm-hmm. Even though you can get scale from a 2D image, it's not the same.
It's not intuitive.
Yeah, so that's the rock. Yeah. I didn't answer your other question. I'll let other
Well,
people.
no, it sort of did, right? 'Cause you're able to bring that in, and yeah.
I mean, details are important, and I kind of am obsessed with the art style of people taking VR into the mundane. Like I have a former classmate called Chris Collins who he teaches gaming at the School of the Art Institute, and his syllabus is in VR, and you have to like smash all of these like coffee cups and just like be in a room and like staple things to like find the syllabus, and a lot of it is just like really mundane, like you just playing chess, or there's one where you're just tapping your hands on a desk. I find that kind of interesting, and that's way different from what I participate in, but it's a very big spectrum of stuff. I think taking real world into VR is just a kind of surreal, cool thing.
So last question, and then we can open up the questions to everybody. But this is sort of a horizon question. But if you had money to fund any project that you could basically just snap your fingers and you have a couple $1 million to work on this, what would it be? No, all right.
I think for me it would be distributing what we do with the devices that we do it in to kids in schools.
Okay.
Because
are you guys doing that at all right now, a little bit? Or
yeah, we are, but
just
like,
more?
yeah, we do a lot of public outreach. It's a huge part of NASA. Like, we have a whole NASA charter, so it's like, as soon as science comes out, we tell the public because you paid for it. But it would be cool if we could have more of a if we could buy a bunch of devices and just like tour them around. That would be a dream.
Just to get in people's hands and just sort of lower that threshold a little bit.
Absolutely. Yeah, we do a lot of stuff with cardboard and Google Expeditions, but that's different than having kids put on the device, because they always freak out and do things that adults don't, like start crawling on the floor, like getting underneath the rover, like screaming, awesome. And it's just really.
Well, I do that, but I'm yeah. Chris, did you have something?
That was a pretty philanthropic idea, and I don't think mine necessarily is. But I would actually really like to see. So I think one of my dreams for VR is I would like to take a room like about this size or maybe bigger, and I'd put sensors all over it, get myself a wireless headset, and I'd like to see urban planning actually done in virtual reality. So buildings, huge buildings, lots of them, entire cities, because one of the things about architecture and construction is that you're not just building a building, you're creating an experience, right? It's all about a human experience. Like when you go to school for architecture, they don't teach you throw some rooms together, make it super cheap. What they teach you is you have to have a concept. There has to be a feeling behind what you're doing. You have to, really be designing something that people are going to walk through. And yeah, there's a bathroom over there, and there's, a fountain over there. But what are they actually thinking? What are they feeling? What's their experience? So, if we could design on a larger scale like that, if we could actually take that to urban planning, we could have more efficient cities that are incredibly beautiful, that really promote like a positive way of life for people.
How many people kind of get it at a quicker?
I mean, there'd literally be no better way to understand how a city could go together and be that perfect unless you're walking through it.
Anybody else want to take on the challenge?
I mean,
what's your next R1?
So when I started my lab a couple years ago, I'm taking a big risk doing VR in building this space, and applying for dozens of grants and getting rejections because maybe people aren't ready for this idea, crazy VR? Idea. Yeah. Finally, last month, NIH is willing to give me $3 million. So, for this virtual reality.
So
project.
was this stuff funded by? It was
funded by my startup funds, right? So my retainment package to not take a job somewhere else.
That's risky. That's awesome.
It's very risky. Yeah,
that's cool.
And it was almost not paying off because I was literally at the ending point.
Oh, that's awesome.
And finally, NIH said, "Okay, we'll take a risk here." But so I am in that position where I've a few $1 million. Of course, UCLA takes a lot of that. But what do you want to do with that? So it's an exciting place to be. But I would still want an extra few $1 million because I'm studying one little area, right? And since I started this lab, there's a dozen labs at UCLA that have ideas for how to merge virtual reality with healthcare treatments or studying the brain. And I always have to I try and help them. I'm collaborating on a few projects: Parkinson's disease, autism, body dysmorphic disorder, which patients are like circling two-dimensional pictures of body weights. I mean, VR is way better than that. And I'm doing this on the side, like with no funding. So with funding, I would just spread it out, right? And there's like a number of different applications: PTSD, education, neuroanatomy education, surgeon training. I mean, there's like a number of areas, and they're not happening because people in the science and medical field just are scared of VR, don't have
It's like,
the
it seems
resources.
gimmicky or like more like entertainment. It's not.
Or
they
think
don't see the
think
utility,
it's
yeah.
not ready yet, which
Yeah.
it's made huge leaps in the last 5-10 years. So that's what I would do, just spread the love and hopefully get a whole bunch of projects going. Because, yeah, some of them are low-hanging fruit. I mean, it's just a waste not to do it.
Yeah, let's open it up. Yeah.
Sasha, I've got to ask. I'm not sure if you can tell us, but your pitch on the curiosity and sort of having it map out made me think of if you've seen Hugh Jackman's Real Steel or Pacific Rim. Is there any work at NASA sort of for virtual reality to be controlling a robot so that it can explore Mars and it can uncover rocks and pick things up and collect things?
So that's not a position. I can't say. No. So no, there's nothing. So rover driving is different than you might expect it to be. All the planning is done way ahead of time, unless there's something specific where Curiosity currently is, as I was mentioning, a scientist wanting a clear image of something that can be a request. So you're talking about robots driving robots, and I love that. There's actually some really cool, my friend in MIT Media Labs is making robots that control robots. We're not currently doing that. Humans still do a lot of the planning. I mean, we do calculations to do that planning, but yeah, that's a really interesting idea. And I'm sure people that are higher up than me in the agency are considering that as a thing, but that's great. Maybe it'll be you, you know?
This is for Nanthia. Especially in the healthcare space, I know that generally people, especially in surgery, would prefer more human interaction with what they're doing. I wanted to ask, where did you start with the idea of using VR in surgeries, as well as like what challenges have you faced?
Yeah, so the chair of the neurosurgery department is really heavily into VR. He's since left last year, but they're still, supporting this idea. It's for, training purposes. It's hard, I teach neuroanatomy with cadavers, right? But it's not quite the same thing, and if VR can get really good enough, or even AR, if you're going into a surgery, there's one person here actually who's developed a way to overlay a person's tumor onto their head that actually is in the right location, and you can also see arteries, right? And so it can kind of help you guide your surgical direction. So for that reason, and also for training, neurosurgeons, it's always better, the more training before you actually get into surgery, and the more realistic it is, the better and more prepared you are. So, you asked where did this idea come from? It just sort of made sense. I don't know where it came from. It just, once VR got good enough, it sort of just, it's like, okay, yeah, duh, we should be doing this. But of course, it's more difficult than it sounds. But there are people that are making headway here. So, yeah.
Hi. So I guess my question is more for Chris and Peter, but this is definitely on the big wish list. But I guess, what are your thoughts on how quickly could we get sort of real-time? Nowadays we have a lot of remote sensing. We have 3-dimensional chemical transport models for things like wildfire smoke, for example. That's currently, a massive issue. So what are your thoughts on, how quickly will we be able to integrate real-time 3-dimensional model and remote sensing information into, let's say, a wildfire scenario to help disaster response? For example, like, maybe the firefighters will be able to see a 3D picture or 3D world of the current state of the fire and the forecast model 2-3 hours from now before they actually go into the field. Again, dreaming big, but I'd love your thoughts on, do you see that possibly happening in the future, and how quickly?
I mean,
Do you want to take it? That was a tough one.
There is data from space satellites that updates really quickly, and we do have, we're working on a 3D simulation of the Earth that will show that in different ways, called Earth, EVRTH. So space data is possible. So taking that and actually making it three-dimensional in the real space. You guys want to take that?
I'm going to add to that. Thank you. One of the things that we can do, so we have drones available to us now, and the technology on that is getting really good. So there's something called drone photogrammetry, which is basically when you take a drone, you fly it over. We can use it on job sites, for instance. That's a practical application for us. And what they do is they photograph the site that you're flying over, and they convert that. It's essentially like laser scanning. So they convert that into a 3D model. So we could take drones, which would really have, sort of no risk of being damaged by the fire if they're extremely high up, and we can actually model that space, and we can capture real-time information about where the fire is located, and then, I'm assuming using other technologies, we could probably map out a plan of attack based on where we think that's headed. But the technology does sort of exist. I think it's definitely getting there.
Yeah, if you want to check out the data, there's a NASA website called Worldview, where you can see all the Gibbs data. It's like many, many data points, it's pretty fun to look through and terrifying and fun.
Any other questions?
So in education, what applications can you think of, maybe even as sort of simplistic as simulations of chemistry labs? And it kind of makes me laugh to think about like how you could simulate mistakes but not hurt them. Mm-hmm. But or chuckle, I guess. But the idea would be, how far out is it going to be before you could sort of have courses that would have a VR lab experiment and something that obviously would be something that you could translate into multi-languages, have it be really accessible.
It actually exists. So my uncle, I plug my uncle's company, he actually does that. So he takes it to, sort of countries that don't have the resources to build these expensive labs. And builds basic labs and uses it in schools. He's actually doing one in New York with a underprivileged school, and it's basically volunteering. So it is happening. And it's sort of basic lab. There are different machines, and you can interact with them, so you can get some sense. And these kids, or even adults in these countries, would otherwise not have any experience with these kind of lab environments. So I think that's a great idea, and I hope to see it get better and more widely used. So
What's the name of that company?
Fab Labs, my uncle's company. It's small. I'm sure there are other people that are working on this as well. But and the limitation is really just how good can you get it in terms of interacting. At this point, sometimes it's like, if you want to rotate a wheel, or it's not like the real thing. If there's some tactile feedback,
yeah.
or the more we get there, the better this will be, and that's what I'd like to see. Another thing I'd like to see in 5 years. So
Yeah, I think there's a huge potential for education in these mediums, and part of it is just a lot of the technology is already there and at a point where it could be very useful, but just constructing syllabi and materials that are, kind of extensive enough to really make them useful it's a big proposition. And so I think that's going to come along with time,
So what would be your suggestion if you were recommending, like let's say Gigi and I are actually on a committee that's supposed to be recommending how we can get emerging technology into the classrooms around the campus. What would it take from a funding perspective and from a staff perspective in your mind to make some of these activities a reality? That a professor could just walk in and say, okay, next fall, let's say the end of the quarter in June, they say next fall I want to have 2 VR experiences in my classroom. How much would it, what would it take us to do that here?
Well, yeah.
Honestly, my lab already, I'm telling you, I use my lab maybe, a few, 1 day a week. There's a lot of empty time in that lab. That's why I keep telling the faculty in my department to use it, even though I'm too busy. But you know why it's not happening, is the VR programmers. That I feel is the bottleneck, right? These folks can make a lot of money in the entertainment or industry world. In academics, they make very little, right? So we have students, and that's what, and I welcome students. So really, that's we need those students. It's absolutely.
But then also, I think an important part would also be scalability of the subject matter, so that if you can create something that has a core budget, but then has wide usability, and that can be distributed, or programs like hers, where she's doing just fantastic work, if that can be made, like I know the California Academy of Sciences is making, I have a friend who's the supervisor, some of their material that they create for their planetarium, they're moving towards VR, and they're trying to scale that so that it isn't just a site-based exhibit, but something that they can push out and be able to use elsewhere. And I think that type of material takes quite a budget to make and takes some time, but then that can really scale very easily once it's made.
So I'll say my lab costs a couple $100,000, right, to build. No, just total hardware. No, total hardware. It's free per hour right now because nobody wants to use it. But it's expensive, right? You can take any one of those cameras and put them on tripods and put them in a classroom here, right? So it's mobile. You could take it somewhere else and do it. So, like I said, I think that the scalability is an issue, but you could take expensive hardware that exists, or even the hardware is pretty cheap, getting cheaper these days to get it into a classroom.
Yeah.
And then you just need those programmers.
And then, make it for PlayStation VR and you got something.
We also have a program, a lot of our developers and designers work with kids that are in schools. We partner with them. We have these partnerships where we have our developers actually work with students to work through problems or give them kind of things to build, and those could be actually building their own environment for their own learning space. So it could be this really beautiful thing. So yeah, that's something we do every year. We've just ended a really great partnership with the University of Washington. We're starting another one this year. So we're really open to doing things like that, especially specifically in our lab.
Okay, I think we need to end because we got some posters that are going to get set up out there, and there's some sandwiches and some stuff for lunch, so go check it out. But thanks for coming on the panel. And thank you. Yeah.
Oh, thank you.